Logarithmic equations. Today we will be solving equations that contain logarithms. When logarithms are present in any equation, we must use several tools to solve them. First, b to the x equals b to the y if and only if x equals y. Now this works for bases greater than 0 and provided the base is not equal to 1. 1 to any power is 1. So we really can't extract information about x equal y in that case. Base less than 0, we run into trouble with square roots of negative numbers and so on. 0 to the 0 power is not defined. So we're going to restrict to bases greater than 0 and not equal to 1. B to the x, an exponential function, and log base b of x, a logarithmic function, are inverse functions of each other, implying that b to log base b of x equals x, and log base b of b to the x equals x. Now we can combine logarithms if the same base is present. We have the sum of two logs equals the log of the product. The difference of two logs equals the quotient of the product. And a power of times a log is the log of a raised to the power. The technique, or to get logarithms isolated. Here I tell you put them on one side of the equation and only logarithms or a single value on the other. The reason is we're going to make these exponents of the base, and we would like the logarithms to disappear. Use the rules for combining logarithms to write the logarithms as a single logarithm. Raise the base to what is on each side of the equation, using that first little rule, b to the x equal b to the n, if and only if x equals n. Then use the fact that logarithms and exponential functions have an inverse function relationship when the bases are the same. And then we will rewrite the equation without logarithms by equating the exponents and solve for x. Finally, we will check our solution because logarithms of 0 or logarithms of negative numbers are not defined, so we have to make sure we don't have a problem. Example, solve for x. 3 log base 10 of x minus log base 10 of x equals 2. When we see log and no base written, 10 is implied. If we see ln, e is implied. So here we have the 3. We need to make a power of x. So we have log x cubed minus log x equals 2. Log x cubed over x, we have a subtraction, so we have a quotient equals 2. And we just combine exponents, and then we make this the power of the base. 10 log x squared equals 10 squared. If we're going to make this the log x squared an exponent of 10, we have to make the other side, the 2, an exponent of 10. Finally, x squared equals 100. That's a simple equation to solve. We come up with the square root of 100, or 10. And we will check that. 3 times log 10 minus log 10 equals 2. Log 10 is log of a positive number, log of a positive number, so it's fine. Technically, we would get another solution of a negative 10. If I put negative 10 in here, we would have to reject it. If only logarithms are present, it is permissible to reduce each side to a single logarithm. Here we have only logarithms. We don't have plus anything. So we'll solve, if possible, the log ln base e of x plus 2 equals 2 log base e of x. Well, this side requires a little work. You must make the 2 the exponent of the x. So we got ln x plus 2 equals ln x squared. Now we'll make our equation, each side of our equation, an exponent of e. So we got e to the ln x plus 2 equals e to the ln x squared. The inverse function of the base and the log of the base makes this x plus 2, and right here equals x squared. No logarithms are gone. We have something we can solve. Simple quadratic. So we solve a quadratic. X squared minus x minus 2 equals 0. In this one, since this is a demonstration of logarithms, there's no point in getting messy with the quadratic formula, so I chose something that would factor. So we got x minus 2 comes x plus 1 equals 0, giving us x equals 2 and x equals negative 1. When we check, we plug the 2 in both sides. The log of 2 plus 2 is the log of 4. That's fine. The log of 2 is fine. So the 2 checks. The log of negative 1 plus 2 is 1. That's okay. But the log of negative 1 is not. That solution does not check, and that must be rejected. Since log of negative 1 is not possible, only 2 is a solution.